Okay, so as a suggestion from one of my students, they said, why don't you start off with a fun math fact of the day? And I Googled something interesting, and it said that a pizza that has a radius z, a height a, has the volume pi times the radius squared, which is zz, times the height, which is a. Therefore, pizza with a radius z and height a has volume pizza. Pretty cool, and making me hungry. Take a break, get a pizza. Okay, so today is 317. We're doing 4.2 similarity transformations. We are also doing checking similarity without transformation. So how can we check similar triangles without transformations? And lastly, using similar triangles. We're going to use similar triangles to find distances of tall objects. We kind of did this in 7th grade in comparing and scaling, but we're going to use it again. But instead of using shadows, we're just going to use distances as mirrors and angles that we can assume are right or similar triangles because they are right triangles and they share the same angle. Okay, so 4.2 says similarity transformations. How can you use transformations to check whether two figures are similar or not? Okay, so here's question A, B, and C. I'm going to do the first one with you, and then I'm going to let you guys use this lab sheet to work on question B and C. Actually, scratch that. I'm going to work on part of question A, and I'm going to let you finish it off instead of me taking all the fun. Okay, so I'm going to see if triangle ABC is similar to PRQ using transformations and our dilations, which we learned last class. Okay, so I outlined ABC in this blue ink, and at first glance they do look very, very similar. They both look like right triangles. So what I'm going to do is I'm going to use my transformations first, and then we'll use our dilations to see if they're similar. So I'm going to translate point B onto point R. So I'm going to translate point B onto point R. And then I'm going to rotate this along point R. So R is supposed to stay still, but it doesn't necessarily choose that point. So here it is. Now, are they similar triangles? How can you use dilation to check if they are similar triangles? If you're not sure, that's fine. Go ahead and stop where you are for 4.2, and we'll finish it in class if you're not sure how you can use dilations to check. Okay, I'm just going to start drawing these lines here so you can see what they look like. Okay, so I'm going to start from point R. Okay, and you're going to measure these sections here. Okay, and then I'll leave B and C for us to do in class. Okay. Okay, so continuing on, we'll do 4.3. 4.2 is pretty quick and easy. We're going to just do this lab sheet using these questions. 4.3 says, how can we check if things are similar without transformations? This is lab sheet 4.3, and this is specifically question E. Before we get there, you can go cut this out and put this in there. But before we get there, we're going to do a couple of other questions first. I'm just going to move this out of the way. Scroll this down a little bit. We are actually going to answer question B first, and there's no lab sheet for this because they give you an idea here. But if you'd like to sketch the drawing, that's a good idea. So what I'm going to do is I'm going to sketch this drawing into my notes, and then I'm going to answer these questions first. If you feel like if all you could do is sketch this drawing, that's fine. And then you want to write down the questions, good start. And then from there, we can answer the questions in class. So A, B, C, X, Y, Z. Okay, A, B, C, X, Y, Z. Okay, so let's go back to this one so I can get the questions to go with this. So we're going to answer question B first, which has two triangles that look very, very similar to each other. I'm just going to quickly sketch it out. So here we go. There's my triangle. And I'm just going to make a smaller version of it. And I'm just going to label my points. I have A, B, C. So A, B, and C. And then I have X, Y, and Z here. So just a real quick sketch. If I had a ruler, if I was doing this on paper, I would definitely do this with a ruler just to make sure that things are straight. And question B, let's just make our quick markings, and we can read over this question later and answer it together as a class if you aren't sure. Okay, so really quickly, a couple marks. I'll make A and X the same, and then C and Z the same. And this one, B and Y, I don't have to mark because they're the same angle. But if you'd like to, you can mark this as 3 marks. Okay. And then we're going to answer question E on 4.3. And it says, the shortcut for proving that two triangles are similar helps verify observations you might have. In the figure below, the equation of the line is y equals ax plus b. That's this line right here. Let's highlight it so we know which line they're talking about. They're talking about this line right here, from here to there. Has this equation. Points P, Z, and W are on the line. Find some similar triangles and explain why they are similar. So there should be some triangles on here, more than one, possibly more than two, and you should be able to identify their similarity. And how does the slope help you? Question E2 says, how does the slope of this line, how does it help you figure out if these are similar triangles? Okay. Again, if you're stuck, feel free to copy this down and paste this into your notebook, and we'll talk about it in class. Okay. Lastly, we have 4.4, using similar triangles, and this is actually using similar triangles to find unknown side lengths. We are actually, what they're telling you is that in this figure is actually in your textbook. It's on page 84. All I did was cut and paste it and put it into my notes. I would just do a real quick sketch. Maybe instead of a stoplight, maybe a tree would be easier to draw yourself, and this would be a mirror. Make sure you label your triangles here, okay? And with your triangles, you should note that these two down here identify themselves as congruent angles. So these two here say that their angles are congruent. So this angle is congruent to this angle. And they are similar triangles because of angle side angle, because I have an angle here, a right angle there, and a right angle there. Okay, so they are similar because of angle side angle, and your last angle would be this one over here. Okay, if I have two angles, I can automatically assume that these two will be the same because they total 180. So I have two similar triangles. If I can measure my distance from my foot to the mirror, right, that should be proportional to the mirror to the base of my tall object, okay? And the proportions of these two should be the same proportion of the height of this person and the height of this stoplight, okay? I would draw a quick sketch. Again, if you'd like to draw something other than a lamppost, that works as well. Make sure you label your angles, and you label this as a mirror, okay? And I'm trying to acquire a few mirrors so we can do this at school, and this activity at school. And it says that similar triangles have the same shape but are usually different in size. You can use the relationship between corresponding parts of similar triangles to solve measurement problems. For example, the diagram below shows a method for calculating the height of an object that is difficult to measure directly. Place a mirror on a leveled spot. That's important, leveled. Okay, if it's not leveled, it doesn't work. It won't assume that these are similar triangles. Step back at a convenient distance from the object. Back up from the mirror until you see the reflection of the top of the object. So when you're looking at this mirror, you should just see the top of the object. Okay, nothing more. The two triangles in the diagram similar. To find the object's height, you need to measure 3 distances and use similar triangles. Okay, so you're measuring 3 distances, and the distances you are measuring are your height, your distance from the mirror, and then this distance from here. Okay, measuring 1, or measure to your eyes, 1, 2, 3, and this will be your x, your unknown. Okay, if you don't remember the equation, you should have your height compared to your distance from the mirror, I'm just going to put m for mirror, should be equal to unknown over the object's distance from the mirror. I'm going to call this object's distance from the mirror. Okay, so this is my OM, and this is my M, and there's my X. Okay, I need to solve this equation using either algebra or scale factor or something. Okay, I need to solve for my tall object. Again, we're going to do this in class. We'll actually hopefully have some time to go outside, and we're going to answer these questions first. We're going to answer questions A and B in class. Again, we'll do this in class. Don't worry about it now. I would just make sure that you have your focus question, your title out of the way, so that way we don't, and your drawing, so you don't have to worry about that later. Leave some space after your drawing so we can go outside and calculate your actual questions. Again, I'm going to go back to your summary and your questions. So summary, how can you use the transformation to check whether two figures are similar or not? Describe how you would find two triangles are similar if you didn't use transformation. So not using transformations, how would you use it? Are there certain requirements that you can look for? And what are the least amount of requirements that you could find? When you look in the mirror, why is it important to see the top of the object you are measuring in the mirror? Why can't you just look for any part? And when you look at it, you know, how are the triangles similar? What angles are similar specifically? And if you're slouching, does that matter? Why or why not? And so again, the questions remain the same. Write a question that you want to know the answer to that I wasn't able to clearly explain. Write questions you think someone else might have. I was like, I think someone's going to be confused about this part, because I was confused for a second, then figured it out. And again, some possible test questions that you think we might have. Okay. Again, copy down your notes, titles, focus questions, and your table of contents. We'll get those things out of the way. We can spend a little bit more time in class working.